students, in today's class we will study about the chapter called chemical bonding. This is one of the important chapter because this chapter gives us concept of formation of compound. How do elements combine to form another compound or molecule? Now, this chapter is essential because it has two main types of chemical bonds, that is ionic bond and covalent bond. The topic from ionic bond will be helpful in studying metals and nonmetals. The covalent bond will help you in organic chemistry. This chapter, this topic is included in class 9th also in chapter of atomic structure, as well as in CBSE class 10th when students have to study the metals and nonmetals. It includes ionic bond, and for the compounds of carbon it includes covalent bond. So I think students, this chapter is one of the important topic related to chemistry at different levels. Now, students, what is chemical bond? Now, as the name suggests, chemical bond. Now, this word means the force of attraction, or that is the linkage between two substances which will hold them together is called simply bond. Now, here is the term chemical bond. So, it stands for the linkage or the force which holds the atoms together in a molecule. So we say here that the linkage or force which holds atoms together in a molecule. Now, whatever may be the molecule, if it is whether it is molecule of element or molecule of compound, the atoms are held together, atoms are combined together, and that holding force is known as chemical bond. Now, here the question arises that why do elements take part in chemical bonding? That is, what is the cause of chemical bonding? So, students, we see that according to the electronic configuration or study of chemistry, we know that in nature there are certain elements which have 2, like helium, or 8 valence electrons like neon, argon and so on, and they are chemically inert, that is, they have a stable outer electronic configuration. They need not require to take part in chemical reactions. They are stable. So, other elements also tend to acquire that stable electronic configuration, and hence they take part in chemical bonding. So, again remember, I am repeating. There are some elements in nature which have 2 or 8 valence electrons in outermost shell, that is the valence electron. They are chemically inert, that is, they are chemically stable. They do not take part in chemical reactions. So, other elements also tend to acquire that stable electronic configuration and take part in chemical bonding or chemical reactions. Now, students, just I have used 2 or 8 valence electrons. Accordingly, it is used as law of duplet. That is, if an element has first cell, that is the K cell, as the valence cell, as the valence shell, then it tends to acquire two electrons in it. Two electrons in it to become stable. This is called law of duplet. Now, next is law of octet. Octet means 8. So, if the valence shell is other than K shell, then it needs 8 electrons in it to become stable. This is called law of octet. So, an element having valence shell other than K shell tends to acquire 8 electrons in it to become stable. So this is called law of octet. Like you see, for example, suppose we have one example, sodium having atomic number 11. It will have this configuration KLm. Now it has one valence electron. In that case, if it will lose one electron, the last cell will have 8 electron in it. It may also gain 7 electron to complete it, but it is easier to lose 1 electron than to gain 7 electron. So it will complete octet by losing 1 electron. Similarly, chlorine has atomic number of 17, configuration 287. This time it will gain 1 electron to make it stable. Here it will have to lose 1 electron in order to become stable, and as a result it will have configuration of 2 and 8. Here the configuration of 2, 8 and 8. So this is called law of octet. Now, so just I have explained that why do elements take part in chemical bonding. Now students, further we have to study here some terms before completely starting with the types of chemical bond. That is the ion. Ion is the charged particle of an element which is formed by loss or gain of electron from the valence shell of its atom. Means we can say that the atom of an element which carries charge is called ion. So ion, the charged particle of an element formed by loss or gain of electrons from the valence shell. Now this is the typical definition of ion. Now as the words use loss or gain, it means that in the two ways the ions can be formed. So accordingly there are two types of ions, cation and anion. Cation is positively charged ion and anion is the negatively charged ion. So basically we have to study these two terms in detail. Like first of all, it is cation, positive ion. It is formed by loss of electron from the valence shell of an atom. Valence shell of an atom. Now, cations. What type of element will form cation? Then elements which will have 1, 2 or 8 valence, 1, 2 or 3 valence electrons. Why do we take 1, 2, 3 only? Because to become a stable octet and 8 electrons is required. The half of 8 is 4. So, if the electrons are less than 4, then it is easier to lose them rather than to gain electron. Now, so in this case you see, that is elements having 1, 2 or 3 valence electrons are metals except hydrogen and helium. They are metals. Elements having 1, 2 or 3 valence electrons are metals and form cation. So one thing is clear here now, that metals form cation. Now next, it means that metals are electropositive elements. Means they will lose valence electron in order to become stable, and they will form positive ion, that is called cation. Now next, one more thing. Among the elements, we will study it, we have studied it in periodic table chapter, that elements of group 1 or 1A are alkali metals, the most reactive metals, and at the bottom there will be, in the 6th period there is cesium, and in the 7th period is the francium. But francium is radioactive element. So cesium is the most electropositive element. Cesium, you must remember here, cesium, Cs, is the most electropositive element. So just I have mentioned about the cation. Now here you can take example. For example, suppose we have sodium, atomic number 11, having electronic configuration of 281. Now you can see, students, here it has 1 valence electrons. So in order to become stable, there may be 2 possibilities. One, it can lose 1 electron. If it will lose 1 electron, the last cell will have only 8 electrons. It will be stable. Similar to the nearest inert gas, neon, having atomic number 10. Next, it can gain 7 electrons to become stable. But this is quite simple, that it is easier to lose 1 electron than to gain 7 electrons. So sodium loses its 1 valence electron and changes to Na plus ion, having configuration of 2,8, that is similar to neon, nearest inert gas, neon. Now how is the charge developed? Here you can see atomic number 11, so proton 11 and electron 11. But on this side, the proton remains as it is, because proton is situated in the nucleus of the atom and it will not take part in chemical reaction or bonding. But the electron is left only with 10. So just you see that there is 1 extra proton that provides its positive charge or develops its charge. So this is the cation. Now one more thing you can remember here, that is, suppose here is the cation. if you compare the size of the atom and the cation, now which one of them will be bigger in size? You will clearly observe that sodium atom has 3 orbits, but the Na plus ion has only 2 orbits. So which is bigger? It must be sodium atom. So we can say here now, students, that an atom is bigger in size than the cation. Now suppose we can take one more example. Suppose we have magnesium, atomic number 12. Its electronic configuration is 2s2. Now you can again see that it has 2 valence electrons, so it will lose 2 valence electrons in order to acquire 2 positive charge. Now, so it loses 2 electron, it forms Mg2 plus, having configuration of 2s only. That is similar to the nearest inert gas neon, having configuration of 2s only. Neon has atomic number of 10. It has 12 protons, 12 electrons, but on this side you see there is 12 proton as it is, but electron has been reduced in number, only 10. So 2 extra proton is there. As a result, it acquires 2 positive charge. So students, it will be easier for you to learn how is the cation formed. Now students, question is asked, that is, differentiate between Na atom, sodium atom and sodium ion. How will you write this answer? So you can compare it in column, this one. It is very easy. Now you see how we will write. This is neutral, electrically neutral, means first difference can be written on the basis of their charge. It carries 1 unit of positive charge, means it is charged particle. Next, it is unstable. It is unstable, means that is having configuration of 281, unstable, but it is stable. It is stable, and since it is stable, it will have free existence in combined, that is in molten state. If an ionic compound will be melted, it can have free existence. Third, now next, it is more reactive. Simple reason, it is unstable. As a result, it will readily take part in chemical reaction. It is unreactive. It is unreactive. The reason is that it is quite stable. Clear, student? Now, fourth, it is toxic. Suppose we engulf sodium metal directly, then being highly reactive, it will react with the different elements or compounds present in our cells, in our body, changing their chemical nature. That will be harmful to us. Hence, it is toxic, but it is non-toxic. It is non-toxic. Like suppose when we eat salt, sodium chloride, then it also contains Na plus and Cl minus. But Na plus ion will be helpful in our different functions. It will not harm us. So this is the non-toxic. And lastly, next point, you can compare their size. It is bigger in size than Na plus ion. And just opposite, it is smaller in size than smaller than Na atom. So these were the different points related to the formation of cation and its property comparison with the respective atom. Now the second type of ion is anion. That is also known as negative ion. Negative ion. As the name suggests, it is formed by gain of electron by an atom. Now again on the similar point, similar basis, you can study about their different points. As you know, as we have discussed earlier, that is elements having valence electrons 5, 6 and 7 are non-metals and form anion. Now you can clearly see that is 4, which was the half of the octet. More than 4 means in order to round off, in order to reach closure, it can easily receive electron. So they will form anion. Next one, that is the point. Now elements, these are, so we can further write here that non-metals are electronegative in nature. Metals are electropositive. Non-metals are electronegative. One more thing which we will study, that is non-metals are strong, or we can say oxidizing agents. That is, they take out electron from metallic atoms and get itself reduced, but cause oxidation of the metals. So non-metals are oxidizing agent, whereas metals are reducing agent. Now we can take example. Again, as we have studied in cation topic, we will again study for anion topic on the similar basis. Like suppose we have chlorine atom. It has atomic number of 17. The electronic configuration for it is 287. Now you see that it has 7 valence electrons. So by gaining 1 electron, it will become stable, similar to the nearest inert gas argon. As a result, this one will gain 1 electron, acquiring a negative charge. It acquires configuration of 287, similar to nearest inert gas argon, having electronic configuration of 288. Sorry, here we have to write 288. So electronic configuration of 288, which is the electronic configuration of inert gas argon. How is the charge developed? There is 17 proton, 17 electron, but here protons are, as it is 17, but electrons are 18. There is one extra electron which imparts 1 unit of negative charge. Now you can take another example again. Suppose we take oxide, atomic number 8, configuration 2,6. This oxygen will gain 2 electron, 6, but needs 8 electrons in the valence shell. So it requires more 2 electrons. It gains 2 electrons and it acquires O2 minus, having configuration 2,8, similar to the nearest inert gas neon. In this part again you see proton 8, electron 8, But in this side proton is 8 but electron is 10. So there is 2 extra electron which imparts 2 unit of negative charge. Now if you compare the size, you can see that is an anion is bigger in size than its atom. The reason is that the orbit remains the same, but due to addition of extra electron, the electron cloud expands. Number of orbit remains the same, there is no change in it, but since extra electron is added, so electron cloud slightly expands, so it is bigger in size. Now this was the method of formation of ion. Now as we have studied in cation part, similarly here is the also question, differentiate between Cl atom and Cl minus ion, that is the chlorine atom and chloride ion. You can again compare on the similar basis. I am not going to write here, but you can use the similar points as we have studied in cation, like it is electrically neutral, it carries 1 unit of negative charge, it is highly reactive, it is stable, unreactive. Now it has a stable electronic configuration, it is unstable. Next, size, it is smaller in size, it is bigger in size. Similarly, toxicity, it is toxic in nature, it is non-toxic. So students, the points which we have written earlier in cation can be easily used to distinguish between the anions, atom and its anion. So this is about the chemical bond, how that is what is the cause of its reactivity, cause of chemical bonding, and the two types of ions.